All right, so you sent over a ton of Azure security docs. I mean, everything from threat modeling to encryption, data classification, the whole nine yards. Looks like someone's serious about locking down those workloads, huh?
You're not wrong there.
We'll get ready because we're diving deep to get you up to speed fast.
What's interesting about Azure security is that it's a journey, not a destination, and it's a journey you don't have to take alone. It's about understanding the why behind the what and
Yeah.
applying these principles in a way that aligns with your specific needs.
I love that, a security journey. So where does this journey even begin? The docs seem to really stress threat modeling as like the first step, but it's not just about the tech team, huddled in a room, right?
Right. It's not just about firewalls and fancy intrusion detection systems. It's about getting everyone on board, including the business folks.
Okay.
Why? Because security decisions need to be made in the context of, what the business is actually trying to achieve.
Makes sense. So the workload team knows where the, technical vulnerabilities might be, and the business stakeholders know the potential impact of, say, a data breach, kind of like knowing where the weak points in a castle wall are, but also knowing which rooms hold the crown jewels.
Exactly. And that's where a framework like Stride comes in handy. It helps classify threats, not just from a technical standpoint, but also in terms of their potential impact on the business.
Okay, so the docs break down Stride with a handy acronym: spoofing, tampering, repudiation information, disclosure, denial of service, and elevation of privilege. Just reading through those, I can already see how each could have completely different consequences for a business.
Definitely. Think about it. Spoofing. Someone impersonating a trusted user to gain access to sensitive data. That could mean reputational damage, regulatory fines, loss of customer trust, the whole nine yards. Now contrast that with denial of service. Sure, it disrupts operations, but the data itself might remain untouched. Totally different ballgame.
So Stride isn't just a checklist, it's a way to prioritize security efforts based on what matters most to the business. So once we've classified the threats, then we can start talking about mitigation strategies.
Exactly. And those strategies might include things like implementing specific security controls, developing incident response plans, or even just minimizing our exposure to those vulnerabilities in the first place.
It all starts to feel very strategic, which I honestly didn't expect going into all this. Okay, so we've got our threat model in place. We know what we're protecting and why. Now it's all about keeping those metaphorical crown jewels safe, and that means talking about data classification. It seems Azure has some serious tools for this, but I'm a little overwhelmed by all the different labels and scopes in the docs.
Yeah, data classification can seem complicated, but it's really about understanding what you have and what level of protection it needs.
Yeah.
Azure provides some built-in tools to help with like sensitivity labels, public confidential secret, and then you've got information types, financial data health records, that sort of thing.
Mm.
And then, of course, there's the regulatory landscape to consider: IPTI, PCI, GDPR, and so on.
Right? It feels like a lot to keep track of.
It can be, but Azure services like SQL Database can actually help you discover, classify, and label sensitive data automatically.
Yeah.
This takes a lot of the burden off your team and ensures consistency across your data estate.
Okay, that's huge. So once we know what we're dealing with, how do we actually lock it all down?
Mhm.
The docs talk a lot about encryption, and I have to admit, this part always feels a bit like a spy movie to me.
Well, in a world where cyber attacks are becoming increasingly sophisticated, that multi-layered approach to encryption in transit, at rest, and even in use is absolutely essential.
Okay, I'm intrigued. Let's start with the basics. The docs mention TLS 1.2 as the gold standard for data in transit, but they also highlight some risks with older protocols. What's the deal there?
Sticking with TLS 1.2 is crucial for secure communication, but you'd be surprised how many organizations are still using older vulnerable protocols because they haven't updated their systems. Those older protocols can have known weaknesses that attackers can exploit to intercept data.
So it's not just about using encryption, it's about using the right kind of encryption and making sure it's up to date. What about data at rest?
Protecting data at rest is just as critical. Imagine someone gains access to your storage account. If the data is encrypted, they're just looking at gibberish without the encryption keys. This is where strong encryption algorithms and the separation of keys from the encrypted data come into play.
The docs really hammer home that separation of keys point. Why is that so crucial?
It's all about minimizing risk. Think about it: if an attacker gets both the encrypted data and the keys, your encryption is useless. Azure Key Vault provides that secure, separate storage and management of keys. Imagine it like a bank vault within a bank vault. Even if someone breaks into the outer layer, the most valuable assets are still protected.
Wow, I never thought about it like that. Okay, so we've got threat modeling informing our overall security strategy, data classification, telling us what needs the highest level of protection, and then encryption locking everything down tight. But then there's this concept of segmentation, which is kind of a new one for me. What's the big idea there?
Segmentation is about dividing your workload into isolated units with distinct security requirements. Think of it like compartmentalizing a ship. If one part is breached, the whole thing doesn't sink. You can segment by subscriptions, resource groups, even deployment environments.
Ah, so if one segment is compromised, the blast radius is contained. The docs kept mentioning perimeter security and least privilege access in this context.
Exactly. And here's where it gets really interesting. Identity becomes the perimeter in the cloud. It's not just about securing your network anymore. It's about controlling who has access to what. We need to enforce least privilege, meaning users only have access to the resources they absolutely need to do their jobs.
So it's not just about locking down the outside of the castle, it's about making sure the people inside can't just wander wherever they want. And Azure provides services to help with this, right?
Absolutely. Azure offers services like virtual networks, network security groups, and Azure Firewall to enforce that segmentation and control traffic flow between different parts of your workload.
Okay, so we're getting pretty serious about security here. But even with all these layers in place, I have a feeling there's always more we can do to minimize risk. The docs mentioned something called hardening.
You get it. Hardening is all about removing extraneous resources and tightening configurations to reduce your attack surface even further. It's like locking down the ports on a ship, disabling anything that's not absolutely essential to its operation.
So how do we actually go about hardening our Azure resources?
It starts with knowing what you have. The docs stress the importance of a comprehensive inventory of your workload assets, servers, databases, applications, the whole shebang. Then you can start looking at ways to harden those assets. For networking components, that could mean disabling unused ports, protocols, and services, or implementing firewalls to control traffic.
What about hardening in terms of identity and access management? We touched on least privilege earlier.
For identity, it's all about multi-factor authentication, passwordless authentication if possible, and implementing those conditional access policies we talked about earlier. You want to make it as difficult as possible for an attacker to gain access and limit the damage if they do. And even with all these measures in place, we can't just assume everything is perfect. We need to be constantly vigilant.
Which brings us to monitoring and threat detection. It's not enough to just set it and forget it, right? We need to actively watch for any signs of trouble.
Absolutely. Continuous monitoring is key. We need to observe both the application itself and the platform it's running on. Are there any unusual access patterns? Is there suspicious activity in the logs?
The docs mention specialized monitoring tools with threat intelligence capabilities. Do those play a role here?
For sure. Those specialized tools can help us detect threats that might otherwise go unnoticed. Think about it. If you only look at logs from a single server, you might miss an attack that spans multiple systems. Centralized threat detection with correlated logs, that's where SIEM systems like Microsoft Sentinel come in. They ingest logs from multiple sources, correlate them, and identify patterns that might indicate a threat.
Okay, so we're monitoring everything, constantly looking for anything out of the ordinary. But what happens when something does go wrong? We need a plan, right? An incident response plan.
Got it. Having a well-defined incident response plan is like having a fire drill for your Azure environment. It outlines the steps to take when a security incident occurs, how to detect it, contain it, eradicate it, recover from it, and then analyze what happened to prevent it from happening again.
That makes a lot of sense.
Yeah.
And are there specific Azure tools that can help with this?
Absolutely. Microsoft Sentinel and Azure Security Center are both powerful tools for incident management and response. It's like having a dedicated security team on call 24/7.
Okay, so we've got our monitoring and incident response covered. But even with the best defenses in place, we can't just assume we're invincible, right? The docs talked about security testing, and it seems like there are a lot of different approaches.
Security testing is all about proactively identifying vulnerabilities and validating your defenses. Think of it like a stress test for your security posture. We've got routine tests to establish a baseline and catch any regressions. Improvised tests to simulate real-world attack scenarios. And then, of course, there's penetration testing, bringing in external experts to try to break into your systems and find weaknesses you might have missed.
Penetration testing sounds intense.
It can be, but it's incredibly valuable. And don't forget about war game exercises where your team can practice their incident response plans in a safe environment.
Wow, it's amazing how much thought goes into all of this. Before we move on to security best practices, there's one thing that really caught my eye in the encryption section, this idea of confidential computing and attestation.
Ah, yes. This is where it gets even more fascinating. Confidential computing allows data to be encrypted while it's being used. It's like having a bodyguard for your data protecting it even when it's most vulnerable. An attestation provides cryptographic proof that the data is indeed being protected within a secure environment.
Okay, my mind is officially blown. That's some next level security stuff right there.
Yeah.
So before we get too deep into the weeds, maybe we should step back and talk about the big picture. What are some of the overarching security best practices that tie all of this together?
That's a great question and a perfect transition to the next part of our discussion. One of the most fundamental best practices is understanding the shared responsibility model for security in the cloud. It's a partnership between you and Microsoft, and knowing who's responsible for what is absolutely critical.
Right, I've heard that phrase before. The cloud provider secures the infrastructure, you secure what you put on it.
Exactly. Microsoft takes care of the physical data centers, the hardware, the network infrastructure. But you, as the customer, are responsible for securing your applications, your data, your identity, and access management. Think of it this way. Microsoft provides the secure foundation, but you build and manage the house on top of it.
And that house needs to be built to code, right? The docs really emphasize the importance of regulatory compliance, meeting those industry-specific regulations.
Absolutely. Depending on your industry and the type of data you're handling, you might need to comply with HIPAA for healthcare data, PCI DSS for payment card data, GDPR for personal data of EU residents, and so on. Azure provides tools and services to help you meet those requirements, but you're ultimately responsible for ensuring your workloads are compliant.
It's like building a house. You need to make sure it meets all the local building codes. So we need to be aware of those regulations and make sure our Azure workloads are designed and operated accordingly.
Exactly.
Yeah.
And that includes things like securing administrative access with least privilege and strong authentication. We've talked about multi-factor authentication and passwordless authentication for regular users, but those same principles are even more critical for administrators. They have the keys to the kingdom, so to speak.
Right. If someone compromises an admin account, they basically have unlimited access to your entire Azure environment. That's a scary thought.
It is. And that's why we need to go beyond just strong passwords. We need to think about things like secure workstations and just-in-time privileges.
Okay, break those down for me. What are secure workstations and just-in-time privileges?
A secure workstation is basically a hardened computer that's used specifically for administrative tasks. It's isolated from the rest of the network and has additional security controls in place to make it much harder for attackers to compromise. Think of it like a separate super secure room in your house where you keep your most valuable possessions.
Okay, that makes sense. And what about just-in-time privileges?
Just-in-time privileges mean that administrators only have elevated access when they need it. They have to specifically request those privileges, and they're only granted for a limited period of time. It's like giving someone a temporary key to that secure room. They can get in to do what they need to do, but then the access is revoked.
So we're reducing the attack surface by limiting the amount of time that administrators have those powerful privileges. That's a smart approach.
Exactly. And another important best practice is protecting application secrets with rotation and secure storage.
Application secrets, those are things like API keys, password certificates, right? Basically anything that's used to authenticate and authorize access to your applications and data.
You got it. And these secrets need to be protected just as carefully as any other sensitive data. That means storing them securely, rotating them regularly, and making absolutely sure they're not hard-coded into your application code.
I can see how that would be a major security risk. So secure storage, regular rotation, what else do we need to consider?
Well, Azure Key Vault is a fantastic service for managing secrets. It provides secure storage, access control, and even automated rotation. It's like having a high-tech, safe deposit box, specifically designed for storing your most sensitive credentials.
Well, that's awesome. So it takes care of a lot of the heavy lifting for us.
It does. And finally, let's talk about securing your development process. It's not enough to just focus on the production environment. You need to think about security from the very beginning of the development lifecycle.
Wait, so we have to worry about security even before the code goes live?
Absolutely. Security needs to be baked into every stage of the development process. This means hardening developer workstations, securing build agents, scanning code for vulnerabilities, and making sure your deployment pipelines are protected from attack. Think of it like building security into the foundation of your house, not just adding an alarm system after it's already built.
Wow, this really is a holistic approach to security. It's not just about protecting the final product. It's about securing everything from the developer's laptop to the cloud infrastructure itself.
Exactly. And the key takeaway here is that security is not a one-time event. It's an ongoing process that requires constant vigilance, continuous improvement, and a commitment to best practices at every level.
Okay, so we've covered a lot of ground here. We talked about threat modeling, data classification, encryption segmentation, hardening, monitoring incident response, security testing, and even confidential computing. But I think the most important takeaway is that security is everyone's responsibility. It's not just the security team's job, it's something that everyone in the organization needs to be thinking about.
I couldn't agree more. From the developers writing the code to the operations team managing the infrastructure to the business stakeholders making decisions about risk and compliance, everyone needs to be aware of security best practices and work together to protect the organization's assets.
And as you said earlier, it's not just about implementing a bunch of technical controls, it's about understanding the business context, making informed decisions about risk, and constantly adapting to the evolving threat landscape.
Precisely. And speaking of adapting, here's something to ponder. We've discussed security throughout the life cycle of an application. But what about the life cycle of the data itself? As data moves from one system to another, from on-premises to the cloud, from development to production, how do we ensure consistent security throughout that entire journey?
Ooh, that's a great question. It makes me think about data lineage tracking and protecting data as it flows through different environments.
Exactly. And that, my friend, is a deep dive for another day.
Data lineage, huh? That does sound like a whole other deep dive just waiting to happen. But for now, I feel like we've given our listener a pretty solid crash course in Azure security.
Yeah, I think we've hit on all the key strategies, and importantly, the why behind them. Security isn't just a checklist. It's about understanding the principles and applying them thoughtfully to your unique situation.
You know, one thing that really stood out to me is how much Azure has baked in to help with security. It's not like you have to go and stitch together a bunch of third-party tools.
Absolutely. Microsoft has clearly made security a top priority, and it shows in the services and features they provide. But yeah, we have to be clear, it's still a shared responsibility. We can't just rely on the platform to do all the work for us.
Right. It's like having a security-minded co-pilot in the cockpit, not an autopilot. They can help us navigate and, point out potential hazards, but we're still the ones flying the plane.
I like that analogy. And that co-pilot is constantly evolving.
Yeah.
One of the most exciting things about cloud security is that it's such a dynamic field. New threats emerge all the time. New technologies are developed. Best practices are always being refined.
Which means we need to be constantly learning and adapting. This deep dive has been a fantastic foundation, but it's definitely just the beginning of our security journey.
Exactly. So as you start applying these security best practices to your own Azure environment, remember to prioritize based on risk. What are your most critical assets? Where are your biggest vulnerabilities? Start there and then build from there, layer by layer.
And don't be afraid to reach out for help. Microsoft has a ton of resources available, documentation, best practice guides, even security experts who can help you, assess your environment and develop a tailored security plan.
Great point. Security can feel overwhelming, especially with so much information out there. But remember, you don't have to figure it all out on your own.
So to wrap up this deep dive, I think it's safe to say mission accomplished. We went from a mountain of Azure security docs to a clear understanding of the most crucial strategies and best practices.
It's always a pleasure to dive deep into these topics. And for our listener out there, remember, security is a journey, not a destination. Keep learning, keep adapting, and most importantly, stay secure.
Well said. Until next time, happy coding and stay vigilant.